Howdy folks, Mr. Reed here, and welcome to one more question. So right now I'm going to be taking a look at evaluating some expressions. I say evaluating, really I'm just going to be changing the form of a few expressions that have some negative exponents on them. So I'm going to do this one at a mild level. I'm actually only going to use integer exponents, so basically negative whole numbers. Just to keep things nice and simple. So if you want to see what things look like when you switch them around due to a negative exponent, you're in the right place. So let's get to it. Okay, I have 3 examples up above. Each one of them is really short, so I'll just hop right into it. That first expression is probably the easiest one to see, and if you've seen what I was talking about in the last video that I did, when I mentioned that the negative exponent actually means a reciprocal, specifically we talked about the exponent of -1. So this -1 exponent means the reciprocal, which for fractions means we flip the numerator and denominator. So all we do in this expression is actually write the old denominator in the numerator position and the old numerator in the denominator position. So 4 over 3 becomes 3 over 4. That's all there is to that. We have actually done the -1 exponent, what that means. We have written it in a new form that no longer needs that -1 exponent. So we're done. Good to go. All right, next up, I am going to take a value of 5 to the -1 power. Now, I actually, at the very end, I decided to talk about 2 to the -1 power in my last video, but I'm going to do 5 to the -1 here as well. This is actually slightly harder to see because a lot of us actually don't naturally see 5 as being the expression 5 divided by 1, which it can be put that way as a fraction. Of course, that makes sense because if we take 5 and divide it by the value of 1, then it leaves us with still plain old 5, which is what we have to begin with. So I'm going to write my 5 as 5 over 1 instead. It's still, I'm going to put a bracket around it just to make it nice and clean, still all to the power of -1. So in this form, 5 over 1, 1 over 5, we're going to do that reciprocal. We're going to do that fraction flip, and so it becomes 1 over 5. So 1 over 5 is the same thing as 5 to the power of -1. Great, so we're just cruising here. The last one is also pretty straightforward. Again, it's written as a fraction, which is a bit helpful. So this is 2 over 5 to the power of -3. And so this time, I usually tell people that the negative part of this exponent is what causes the flip, and then we still have the exponent of 3 to apply. The reason why that works is because there's an exponent law that we usually do in the reverse of what I'm going to show you right now. So normally you could see something that looks like this, and I'm going to put a second bracket around it for a moment. So it looks like this, and we would say, oh, when you have an exponent raised to another exponent, so there's a second set of brackets in this case with a 3 on the outside of that, then we can take those 2 exponents and multiply them together, and it gives us the single exponent that we have here at the beginning expression. So I can also apply that rule in reverse. So I started with a -3. There's no reason why I can't pull that apart into a -1 and a 3 done separately. If I do that, then this part right here, that only includes the -1 exponent and the 2/5 fraction, but does not include the 3 that's outside of that. That actually can be done just the same way as our first example here, where we had 4/3 flips to give us 3/4. In this case, 2/5 flips to give us 5 over 2. So my orange part of this expression becomes 5 over 2. I have actually used the -1 exponent, so that no longer gets written in. This is still inside of, last time I used kind of a square bracket there, so I'll keep it the same way. So we have a square bracket with the power of 3 kicking around the outside. Just to slow this one down and make sure we're on the same page, this is equal to 5 halves times 5 halves times 5 halves. The reason I know that's true is because an exponent that's a whole number like this is another way to talk about it is by saying it's repeated multiplication. So something times itself 3 times here. So 5 halves times 5 halves times 5 halves. Really taking our time, 5 times 5, because when you're multiplying fractions, you multiply your numerators together, you multiply your denominators together. So I'm just going to do the first two actually. 5 times 5 is 25, and 2 times 2 is 4. And that's our answer for the first part. I still have a 5 halves kicking around at the end. If I multiply those ones together, I get 125 in the numerator, and we get 8 in the denominator, which is an alternate expression, I guess you could say, my evaluation, if you wish, of what the original expression was. So a couple of them I just changed the form a little bit. You could argue that it's not much of an evaluation. The last one I definitely did a little more with. So in the beginning, it is a fraction to the power of -3, and then in the end, I actually have this expression that's just a single fraction. So that's all there is to it. That was at a mild level, just a few nice examples. We can mix this with what we've learned about rational exponents beforehand and get a little bit fancier. If you want to make questions a little bit more difficult, you can just throw in some random things that are described in decimal values instead of being in these nice fraction forms. I know that sounds really weird, especially for those of you that got used to the decimal system first in your education, which is most of us, I think. But fractions are by far the nicer things to work with, at least from a mental point of view, being able to do some stuff in your head. All right, so hopefully you found that one helpful. If you did, like, subscribe, and as always, take care, folks.